Hello everyone, I hope you are doing well. So in this video, we're going to discuss the first three problems of Codeforces Round 885, which was rated for Division 2. So I know this video is a bit late. Actually, I was not able to give the contest because I reached my home late and I did not get much time because I was busy with some personal work. So the only reason why I'm recording this video is because I had uploaded a post asking whether you want an tutorial or not, and I believe a lot of people had voted yes that they want an tutorial. So here it is. Now for this contest, I would say, like, I read the comments on the blog posts of this contest and I realized that the problems were a bit tricky than usual, and I certainly agree with that particular view. The problems were tricky, but I believe they were not very difficult. It's just that the observation was a bit tricky. So let us start with the first problem. Now with this particular problem says that we have been given a coordinate in which our player Vika is standing, right? So let's assume that Vika is standing at a particular coordinate and they have given us the coordinates of all of her friends, right? So we have two types of coordinates. One is coordinate of Vika and there will be k coordinates, which are the coordinates of her friends. Now we have to tell whether there will be any moment in which Vika and any one of her friends are standing at the same box or same location. So let us discuss this with the help of an example and it will be much more clear to you. So let's say we have some grid like this, right? So let's say our player Vika is present here and one of our friends is here. Now some other friend can be here and some other friend can be here. Now after each minute what will happen is they have to shift their position by 1 unit. So they can travel up, they can travel left, and they can travel right and down. These are the four directions they can travel, both Vika and her friends, right? And it is compulsory for them to move in at least one of the directions. Now this is our first thing, that they will move and they will definitely move in one of the directions. And we have to tell after the end of any minute, let's say after X minutes, whether Vika and any one of her friends are standing at the same box. So let me give you an example of what I am trying to say. So let's say there are two boxes like this. Vika is present here and her friend is present here. So if Vika is trying to move downwards and her friend is trying to move upwards, then after they have both moved, their positions will be like the Vika will be present here and her friend will be present here, right? So this will be the final position, right? And in this case, you will see that they are not at the same square or at the same location, right? So this will not count. It should be a situation like this where Vika is present here and let's say her friend is present here, right? So let's suppose Vika move upwards, her friend can also move leftwards and they will end up in the same position. And for example, Vika moves right and her friend moves downwards and they will also end up in the same position here, right? So this is the case when Vika will get stuck and we have to print no. Otherwise, if Vika can forever run and she will never get stuck, we have to print yes. So the observation to this particular question was that you look how a normal board game looks like. So if you assume, if you take an example of a chessboard, right? So let's say this is black, this is black, this is black, and then this will be black, this will be black, right? So the board game is something like this. Let me just draw it completely. And this one, and then this one and this one, right? So you will see whenever I'm at a black square, no matter what move I make from any black square on the board, I will always move to a white square, right? And if I'm a white square, if I'm at a white square, no matter what move I make, I will always move to a black square, right? So these are the two things that you need to keep in mind. Now let's suppose Vika is standing at a black square, right? And all of her friends are at some white squares. No matter which square it is, they are just at some white squares. Now after one move, Vika will move to a white square and all of her friends will move to a black square. So this is after one move. After two moves, Vika will move to a black square and all of her friends will move to a white square, right? So you see, this will continue on indefinitely and the color of their squares will never match. So if the color is not matching, they can never be on the same square, right? So this is one thing. Now if any of her friends is at the same position as Vika or has the same square as Vika, same colored square. That means if Vika is at black, at least one of her friends should be at black. If this is the case, then she cannot run. Otherwise, she can always run. Right? Why she can always run? Because her friends will never be able to reach her square because their colors will always be different. So there should be at least one friend of Vika which has the same color as Vika. Right? So this was the observation. Now how do we actually find this particular thing? So let's say this is 1, 2, 3 and this is also 0, 1, 2, 3. So you will see whenever the sum of the axis is odd. So if this value is odd, then we are standing at a white square. Otherwise, we are standing at a black square. So you can also take the other way around. You can consider this as black and the other one as white. It doesn't matter. It's just that we can like differentiate between the squares by this particular attribute that the sum of its row and column value should be either odd or even. All of the values that are odd will be of one particular color and all the other values that are even will be of the other color. Right. So this is all that we had to discuss about this particular problem. Now let me just show you the code how I did it. So you will see that we have taken some input n, m and k and she has k friends. So I am taking pairs of integer and integers and I am taking input in this vector of size k. Now I am just traversing through all the values and I am taking the indexes a and b. Now if x plus y and 1, that means the color of the Vika's cell and the color of our friend cell are equal, that means the answer should be no. That means Vika cannot escape and there will be at least one moment then when they will get stuck and I can just return from here. Otherwise at the end I can just always print yes. Right. So this was the solution to the first problem. Now let us have a look at the second problem. So this question is Vika and bridge. So this question says that we have been given an integer n and there are some paints that are associated with each of the steps of the bridge. So let's say there is a value of n. So if we have some n, then that means there will be n steps on the bridge, right? And each of those steps is painted with one of the k colors, right? So this is the value of k, that is 2 here. So each of the color can be from 1 to k. Now you can see that the first step is painted with 1, the second step is painted with 1, third step is painted with 2 and then 1 and then 1. Now our task is basically that we want to go from the starting position, this particular position, to the last position by only stepping on the steps which are of same color, right? We have to only step on those steps which are of the same color and in the process we are allowed to change at most one step, right? We can change the color of any one of the steps we want in this whole bridge. Now there is also one more interesting thing, that we can make some jumps. So if I am at position 1, I can directly make a jump to the last position, right? This is also possible, but I definitely want to reduce the maximum jump I have to make through the course of this traversal, right? So I want to minimize the size of jump. This is one point, and I have to only visit same colors. This is the second point, and I can change the color of any one of those steps. Remember, I can only change only one color, right? So this is the third point. Now we have to find what can be the minimum size of the jump that we can have. So earlier I thought that this problem can be solved with binary search, but I was wrong because the function will not be monotonic the way I was trying to solve it. So I figured out that there is also a greedy solution to this particular approach. But before that, let us discuss an example of how this question works. So I'm going to take this particular sample test case. So the answer is 2 for this sample test case. So we are just going to take it and discuss how it can be 2. Right. So you see that the values are 1, 2, 3, 4, 2, 3, 1 and 4. So I believe like you can take this 3 and this 3. So if you are starting from here, right, starting from here you will have to jump 2 stones, that are these 2 stones, and then you can reach position 3. Now you again have to jump 2 stones and then you can reach this particular stone 3, and then again you will have to jump 2 stones and you will reach this particular position, last position at which you have to go, and you will be able to cross the bridge with a maximum jump size of 2. So for this particular case you didn't have to change any color and you were able to cross the bridge with the maximum size of 2 and without changing any color, right? But there might be cases where you will have to change color. For example, if I write some random integer, let's say 6 here, right? Now if you make this jump will be of size 3. So what I can instead do is I can change the color of this particular 6 to 3. Now if it becomes 3, this becomes 3, I can make a jump from here to here and then from the second 3 to the third 3, right? So you see the jump in this case is of only one element, right? I am skipping only one element in between, and here I am skipping 2 elements, so the maximum value is 2, so my answer will be 2. And this is the minimum value of the jump size that I can create in this particular test case, so this will be my answer. Now how do we actually solve this particular question? For us, let us try to solve a smaller problem first. Now let's say I have a 3 here and I have a 3 here, and let's say there are some values in between, and I want to go from this 3 to this particular 3, right? So if I am allowed to make one of these stones equals to 3, which stone should I pick? The obvious answer is I would like to pick the middle stone, right? So in this case, the number of stones between these two threes were even, right? So there are 6 stones, right? Now in this case, you will realize the size of the jump, the maximum size of the jump will be 3, because if I go from here to this particular 3, the size is 2 here, and from this 3 if I go to the last 3, the size is 3 here. So the maximum jump is 3, right? Which is equals to this number of stones divided by 2. So this is 3 in this case. Now let's say the number of stones were odd, right? So I have odd number of stones between them. Again, it is always optimal to place the stone in between, but in this case, the number of jumps that I have to make, or the size of the maximum jump that I have to make, is 2, right? So this is 2 and this is 2. So in odd case also, it is going to be n by 2, and in this case it is 2. So the value of n is the number of stones between two stones of same color, right? So that means if I choose 2 stones and I want to place a stone between them, it is always optimal to place the stone in the middle position, and the maximum jump that I'll have to make in such a case will be n by 2, right? Now there will be not only 2 threes in the problem, but there can be multiple threes. So right now you must be observing that I am only considering one particular color, but we will later see how we can expand to multiple colors. So let's say there are multiple threes like this, right? So there will be some elements in between these, some element between these, some element between this, and so on. There is 1, 2, 3, 4, 5 and 6. So let's say this is the number of stones itself, right? So in between these two threes there is one stone, between these two threes there are 2 stones, here 3, here 4, here 5 and here 6, right? So my obvious answer would be to color a stone in this particular gap so that I can try to minimize my maximum jump, right? So if I do this here, the maximum jump now that I'll have to make in this range will be 6 by 2, and that is 3. So this is one of my answers. Now the problem is, when I try to put or color my stone here, the new problem that is present with me is that the number of stones between these two threes is 5. So here I have to make a jump of 5. Here in this case, I was able to reduce the size of the jump here, right? Between these two threes, I was able to reduce it to 3, the maximum size of the jump. But still, the maximum size of the jump is going to be 5 between these two threes. So I'll have to take the maximum of the best value. The best value means the greatest value. Let's say this 6 was the greatest value, so I have to take 6 by 2 and 5. So 5 is the second greatest value. Why only the second greatest value? So if I have considered this particular jump of size 5, then these smaller jumps will already be considered, right? And I can prove that this is the only optimal place to place a stone or to color a stone. Why? Because let's say for a moment that you try to color a stone between these two threes. So we try to color a stone in this gap of 5. So this gap will eventually reduce to 2, right? Because 5 by 2 is 2. But still, the number of stone between these two threes is going to be 6. So my maximum answer is still going to be 6. So in the best case scenario, it is always optimal to choose the maximum distance and divide it by 2. Now, as we have already seen in this example, even after choosing the maximum distance and dividing it by 2, there can also be a second smallest distance which will be still greater than this value. So in this case, it was 3 and 5. Now this distance has not been considered, so I have to consider the second greatest value. Once I consider the second greatest value, all the other values that I have, these values will already be considered, right? They will be already taken into account because I have taken a greater value. So that means for each of those colors, let's say there are k colors, I can try to find the answer by just maintaining the maximum and the second maximum value. So for each of the k values that I have in my answer, let me just say that I have all these maximum and second maximum values, and with the help of these values I can find my best answer for all those k, right. So what will be the answer for my k? It will be the maximum of max value which comes from here, max by 2 comma second max, right. So the maximum of these two values will be my answer if I try to jump through the stones of color k, right. So I can do this for all the colors, I can take the minimum of all the answers. So this was the solution to the second problem. Now let us have a look at the code. So you see what I've done is, to maintain this best or the maximum and the second maximum distance, I'm using a multi-set. You can use a priority queue as well, or you can use any other data structure that you find suitable, but here I have used a multi-set. So now what I do is I create a vector. So first of all, I'm taking two integers n and k, taking input, and I'm taking input in a vector of size v. Now I'm creating a vector last, which is going to store the last position at which my kth color was observed. Now I create a multi-set for all those k colors. Now this will be storing the maximum and the second maximum number. Now what I do is I create a for loop and I calculate the value of jump. So what will be the value of jump? So I am at currently position I. Now the last position at which my current color was observed was last of v of I. So v of I is my current color. Last of v of I was the last position at which my current color was observed. So if I am looking at color 3, last of v of I will give me the last position of 3 before the current position. So the number of elements between these two positions is going to be I minus last of v of I minus 1. Now I can just update last of v of I with I here, and I can just insert this jump value in the distance vector. So distance of v of I dot insert this particular value jump. Now since I only want the greatest two elements, I can just start removing elements from this distance vector if the size of this distance vector is greater than 2 for any v of I. Right. So while this size is greater than 2, I can just start removing the element present at the first position. So the first position will be the smallest. Since I want the greatest 2, I can start removing from the smallest positions. Right. Now what I do is I can initialize my answer with n, because this is going to be my maximum upper bound. What is the worst case? I can try to jump all the stones. Right. So in that case my answer can be n. So this is my worst case, and I can start a for loop starting from 0 till k plus 1. So this is going to go through all the k colors, and if last of I is not equal to minus 1. So I initialize all the values in the last vector with minus 1. So it is only going to be minus 1 if it is not present in my array itself. So if it is not minus 1, I can create one more jump. So the reason why I have done this part, so this is the exact same part that I am doing here. I am calculating jump and inserting into this distance vector. The only reason I am doing this is because I also need to consider the jump that they have to make to go from their last stone to the last position. So let me just also explain this part. So let's say this is the array. You are currently at position this one, and you also have to go till here. So you also have to consider these elements or the jump made by you to cover these elements, right? So that is why I again do the same thing. Just instead of index I am taking index n, right? So this is the last position after all the steps has been crossed. Rest of the things is exactly the same. N minus last of I minus 1, and I insert it into my jump vector, and if the size is greater than 2, I just remove it. Now I just copy all the values from my distance of I into my values vector. So v of 0 will be the second greatest value, and v of 1 will be the greatest value, since this was a multi-set and all the values were arranged in order. So I can update my answer as minimum of answer comma maximum of these two values, which is values of 0, that is the second greatest value, and values of 1 by 2, which was the greatest value. Now I can just return my answer, and this will be the solution to the second problem. Now let us have a look at the third problem. So this problem was a bit tricky, but let us try to make some observations and try to understand what can we do about this particular problem. So this says that we have been given two arrays A and B. Now we can perform one operation in which what we can do is, so we can set C of I as absolute value of A of I minus B of I, right? So after setting each C of I for all the indexes from 0 to n minus 1, so we have to rename array C into array B and array B into array A. So basically all the values that were present at array B will be shifted to array A, and all the values that were present at array C will be shifted to array B, right? So this is what they are trying to say. Now we want a state in which all the values in array A are 0, right? We want a state in which all the values in array A are 0, and we have to tell whether it is possible to do it after some number of moves or not. If it is possible, we have to print yes, otherwise we have to print no. So let us see an example. So for this particular test case, the answer is yes, and we will see how it is coming out to be yes. So you see that we have this test case and the values are 1, 2 and 3 in both of the arrays. So when in one operation, let's say this is A, this is B and this is C. So in one operation, we have to take this difference. So this will be 0, 0, 0, and after the completion of the first operation, A will become 1, 2 and 3 and B will become 0, 0, 0 and C will be discarded. Now we have to form a new C. So C will be like, this is 1 minus 0, so this is 1, 2 and 3 respectively, and then after the completion of the first operation, this will become A will become 0, 0, 0 and B will become 1, 2, 3. So we have reached a state where all the numerators or all the values in the array A are 0. That is why the answer is going to be yes. If we cannot reach a state like this, the answer is going to be no. Right. So let us make a couple of observations in this particular case. So we are making some observations. Right. Let's say the value of A is 0. Right. Let's say the value of A is 0. What will happen in this case? So you will realize if there is a value 0 here and there is a value B here. Now let me try to make one move. After one move, B will come upwards and B will be downwards as well. You can try to solve it. Also let me show you quickly. So this is going to be C is going to be 0 minus B, an absolute value. So B is going to be in the denominator as well as the numerator. Now if I make one more operation, this is after the first operation. Now if I make one more operation, now this in this case C is going to be 0 because B minus B is 0. So B will come upwards, this B will go upwards and denominator will be C. So this is the value after the second operation. After the third operation, what will happen is B minus 0, in this case C will be equal to B. So this 0 will go upwards and this will be 0 and this will be B. So that means I can make any number of moves. If the numerator becomes 0, I can make any number of moves. If it is a multiple of 3, it is still going to be 0. So let's say I was able to reach this particular state after 7 moves, right? So if I make 10 moves, then my numerator will still be 0. And if I make 13 moves, then it will still be 0. If I make 16 moves, again 0, 19 moves, again 0, right? So this is how it will continue. This was my first observation. Now the second observation is, this was first observation, and the second observation is that the value of B is 0. Value of B is 0, and let's say the situation is like this. So you see this is the same as this one. And after it, if I make one more step, exactly one more step, then it will become 0 upon A. Right. So I am writing it as a fraction, but it is not actually a fraction. This upper value is going to be a part of the array A and the lower value is going to be a part of the array B. So I am just saying it so that you don't confuse it with the fractions. I am just writing it for the simplicity of writing. So after exactly one step, I was able to convert this position into such a position such that the value in array A becomes 0. Right. So these were the major two observations that we needed to have to solve this problem. Now let us discuss some other observations as well. There are a lot of observations, and then we will try to combine them and form our best answer. So let's say the numerator value is greater than the denominator value. Let's assume this for now. So let's say A by B is my current value. Right. Now I make one operation. After one operation, what will happen is B will come upwards and the denominator will become A minus B. Right. So you must have studied this. Right. So if x minus y is written like this, there are actually two ways of expanding this. So it can be either x minus y, or this can be either y minus x. So the value is x minus y if the value of x is greater than y. It is y minus x if the value of y is greater than x. Now that we know this, as we have already discussed, A is greater than B, so it is going to be A minus B. Right. Now let us make one more move. So after the second move, what will happen is A minus B will go upwards, and in the denominator, let's say this particular value is still greater than B. So it will be A minus B minus B. It will be A minus B minus B. So it is essentially going to be A minus 2B. Let me make one more move. After my third operation, what will happen is A minus B will come upwards, and if I try to calculate the value of C of I, it will be A minus 2B minus A minus B. So it is essentially going to be, this a will cancel this one, and this will be minus b. So essentially it is going to be b, right? So minus b and b is in the same, because we are taking the absolute value, that is why I can write b. So after two operations, whenever we considered a was greater than b, after three operations, the final value was a minus 2b by b, right? So there are actually two reasons why I went in this particular direction. The first thing was I observed was, after three operations in this case, I was able to find the same value. So that means I can try to do something in multiples of 3, right? So this was my first observation. So this is the reason why I am trying to get in this particular direction. And one more thing about this particular observation is that we initially considered a minus b, but you will see while trying to get to this particular stage, we also had a situation where we considered that a minus b is greater than b. Only then, when we considered this, we were able to write it as a minus b, right? Remember, we wrote this a minus b, or this value of c of I, as a minus b. We were only able to write it because we considered a minus b is greater than b, right? So if this is true, then a should be greater than 2b. So the correct relation should be a should be greater than 2b. I know that you guys would be a little bit confused of how can I make this conclusions. The first thing is, I already told you that I was trying to do something with 3 number of steps, right? Because I already know that I have something with 3 steps. So I was also trying to do something similar with 3 steps here. When I'm trying to do something with 3 steps here, the one of the ways to expand a by b was this one, right? Obviously, you could have also assumed that a minus b is less than b, but it could have not taken you anywhere, right? So it was better to assume that a minus b is going to be greater than b, and then you can write it at like this, and then in the third step it will become like this. So I have carried forward the same observation here, that a minus b is greater than 2b, right? So you can also write it as greater than equals to, it is also going to be the same, right? Now the fourth observation, I wrote it for a, right? Now I can also write it for b. Let us assume that b is greater than 2a. What will happen in this particular case? So if b is greater than 2a, that means the denominator will come upwards, or the value of a will be like this, and the value of b will be b minus a this time, right? So this will be b minus a this time, because b is greater than 2a. Now coming on to the next step, again b minus a will move upwards. Now again I can write it as b minus a minus b, right? So this is after the completion of second step. So I can also write it as a, right? I can write it as a. So if I make one more operation, after the third operation, what will become? This a will move upwards, so this will become a, and in the downwards that we have b minus a, right? So why am I writing it like this? I am assuming that this value is going to be greater than 0, and I made this assumption here. So b is greater than 2a means b minus 2a is also greater than 0, right? So this is the same assumption. Why am I writing this way? So it is essentially going to be b minus 2a, right? So this is the second thing that we have. So we have made a lot of observations till now. The first observation was, if 0 was in the numerator, after 3 steps it will again be in the numerator. If 0 is in the denominator, so you can ignore my words numerator and denominator. I am saying it again and again. I am just only saying it for the sake of simplicity of writing and speaking. Numerator does not mean it is in fraction. It only means that these are two different arrays, a and b. A is present upwards and b is present outwards. So if b is 0, or the number below is 0, then it is going to take one step to make it upwards, or to move it upwards. Now if a is greater than 2b, that in 3 steps we can achieve this particular state, a minus 2b upon b. If b is greater than 2a, then we can in 3 steps achieve this particular state, a by b minus 2a. So now let us look, what is the actual significance of all of these observations that we are studying. So the final thing is, let's say there are some elements like these, right? And let's say you were able to bring the first element in a state like this, 0 by b. So let us assume that you were able to do it in 5 steps, right? If you were able to do it in 5 steps, and you have some state x1 y1, x2 y2, and x3 y3 here, right? Now let us assume that you are able to do it in let's say 8 steps, you are able to do this one in 11 steps, and you are able to do it this one in 14 steps, right? So what we are trying to do is we are trying to make x1 equals to 0, x2 equals to 0, and x3 equals to 0. For this, we were able to make it in 5 steps. For this, we are going to take 8 steps, 11 and 14. So you see, if after 5 steps I made this equals to 0, then after 3 steps again, that means when we reach at the end of 8 steps, because 5 plus 3 is 8, x1 is going to be 0, and this first number is also going to be 0, because we have made 3 steps, and we already discussed in observation number 1 that after any multiple of 3, if we make that number of steps, it is again going to be 0. Now again we make 3 steps and we total make 11 steps. So now the first position, the second position and the third position are going to be 0, right? Again we make 3 steps. After a total of 14 steps, all of the 4 positions is going to be 0. So did you observe something? That it was 5 here, it is 8 here, it is 11 here, and it is 14 here. No matter what steps we are taking, if the value modulo 3 is the same, that means this value in this case is 2. 8 modulo 3 is also going to give 2. 14 modulo 3 is also going to give 2. If it is going to give the same remainder after dividing by 3, that means we can have all of them as 0. So now our question reduces to finding the number of steps that it takes to convert a number from a by b or a and b to 0 and something, right? We want to achieve this particular state, and we want to find how many steps will it take for the current number to do this. So let's say if you are able to do it in y steps, so we need to find the value of y mod 3. If this value of y mod 3 is same for all the indexes, then yes, we can find our answer, otherwise we cannot find our answer. So this was the crucial information or the crucial observation in this particular case. Now the question is, how are we actually going to find this value, or how are we actually going to find the number of steps? Now comes into picture the other observations. So you see, if the numerator, if the value of a is 0, then the answer or the number of steps is going to be 0. If the value of b is 0, then the number of steps is going to be 1. So 1 step, right? So this one. And if the value of a is greater than equals to 2b, then we see after each 3 steps it is going to reduce to a minus 2b by b. We can try to do this until this value is greater than 0. If we make 3 more steps, it is going to be a minus 4b by b. If we make 3 more steps, it is going to be a minus 6b by b, right? And so on. So we cannot continue indefinitely decreasing this. We should continue only till a minus 6b or a minus some m into 2b is greater than equals to 0, right? So after some m number of operations, this value should be greater than equals to 0. And we don't know the value of m, but we are just considered about the number that will remain at the top. So that number is actually going to be a mod 2b. So let's say we have some numbers a and b, right? And I'm saying that I can subtract b like this: a minus b, a minus 2b, a minus 3b, a minus 4b, and I can keep subtracting this until this value is greater than equals to 0. So I'm just saying, what is the value that will remain at the end? So after subtracting some multiple of this number, I'm going to get some other number. Does this equation seem familiar? Does this equation seem familiar? It is nothing but the equation of a normal division operation, right? So this is going to be the dividend, this is going to be the divisor, this is going to be the remainder, and this is going to be quotient. So we were interested in this value of r, and we can just find it by doing modulo. We are just interested in finding the remainder. So I can write, or I can replace this whole value by a mod 2b by b or comma b. Now one more interesting observation is that we are always doing this operation in a multiple of 3. So while counting the total number of steps, we can completely ignore these number of steps. Why we can ignore this number of steps? Because the number of steps will always be a multiple of 3, and since we are anyways finding at the end number of steps modulo 3 here, so we can also exclude this and do not count this number of steps. We can just directly transform this a and b to a mod 2b and b, right? We can do the same thing with this particular thing, when we have A and B, we can write it as A and B mod 2A. And we again do not need to count the number of steps because they are always going to be a multiple of 3, and anyways we are at the end going to do y mod 3, so we don't need to count it, right? And the last thing, if it is none of these cases, we can count the number of steps as 1 plus b comma, we can call our helper function or whatever it is, absolute value of a minus b. So this is what we actually had in the beginning, right? So if none of the conditions are satisfied, if none of these conditions are satisfied, we can anyways find the values like this, right? So this was the whole solution of the problem. I know that this is a bit tricky, but let us have a look at the code now. So this is my code, and what I have done is I have created two vectors a and b, and I have taken input in it. I have created a map. This is my helper function. We'll discuss in a while why we need it. And we run a for loop, and we have this if condition in place. So actually I forgot to mention it, but this is not very difficult. If both of them are 0, let's say we discussed when a was 0, a of I was 0, we discussed when b of I was 0, but what happens when both of them are 0? So in this case, no matter what number of operations you make, they are anyways going to be 0. AI is always going to be 0. So we only need to consider the case when either of AI or BI is a non-zero value, right? So what I do is, whatever value I get this from helper function, I modulo it by 3 and I store it in my frequency map, right? Now what I do in my helper function, I am taking two variables. If x is equal to 0, it will return 0. If y is equal to 0, it will return 1. And as we have discussed, if y is greater than 2x, we are going to return helper of x comma y mod 2x. In this case, we are counting the total number of steps. So from x comma y, we are moving to this particular state, x comma y mod 2x. So obviously we would have made some operation, only then we would move from x comma y to this particular state. But since those number of steps were always a multiple of 3, I am repeating it again, we don't need to count it because anyways we are going to take modulo 3. That is why I have not counted the number of steps here, right? Similarly, I do for the same thing for y is greater than or equal to 2y. I am calling helper of y mod 2y comma y. Now, if none of it is the case, I am just calling 1 plus helper of y comma absolute of x minus y. So, like this whole algorithm will work in n log n. This helper function is supposed to work in log n. Now, I don't have a mathematical proof of why this should work in log n, but I can try to give you a general intuition of why this is true. So when we talk about this GCD function, so in GCD function we do something similar. We take b and a mod b. So we know that the overall complexity of this GCD function is logarithmic, right? Here we are also doing something similar. We are taking x and y mod 2 into x. So like it's just based on a rough intuition that this helper function should work in logarithmic time complexity, right? Although I'm not sure what should be the exact complexity of this, but it's just an guess that it should be logarithmic, and obviously it passes, so it will be logarithmic in nature. So at the end, what I'll do is I can just check if the size of my frequency map is less than 2. That means there are less than 2 unique values. So there will be either no value at all or there will be only one unique value. In that case, the answer is yes, otherwise the answer is no. So this would be the solution to the third problem. I hope that you guys were able to understand the solution. If you guys did, then do consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you and to be able to reach more number of people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost, and you can always unsubscribe if you don't find the videos interesting later. So share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.